Okay, now let's quickly do this one. So the question says a box contains 4 red balls and 6 blue balls. 2 balls are drawn without replacement. What is the probability that both balls are red? So we have 4 red balls and six blue balls. So this is without replacement, right? So if it's without replacement, it means we are dealing with dependent events. Okay, so we have two events here because they are saying 2 balls are drawn without replacement. So let's have the first event. The first event is this one, and the second event. So let's see what we have. We have red here, red balls, blue balls, red balls, blue balls, red balls, blue balls, right? So now let's put in the numbers. We have 4. So first we need to combine, we need to add these two. We have 4 plus 6. This should be our denominator for the first event, right? So it's going to be 10. We are going to have 10, 10, 10. So this is our denominator for the first event. Now, how many red balls do we have? Red, we have 4. We're going to write 4 here. And then blue, we have 6. We're going to have 6 here. Now, let's go to this one. So they are saying without replacement. So it means when you take out something, 1 ball, you're not putting it back. You take out, so the number reduces, right? So now, suppose in your first when you were taking out the first ball, you took out red, right? If you take out red, how many reds are we going to be left with? We have 4 reds. So if you take out one, we are going to be left with 3. And then if you take out 1 ball out of 10, how many are you left with? Because we are not putting it back when we take it out, right? It's without replacement. So we 1 10 take away 1, we are going to be left with 9. It's going to be 9 here. So it means the second event, our probability, our denominator, I mean to say, is going to be 9 here and 9 here, right? So if you take away or take out 1 red ball, did you touch any blue balls? You did not touch any blue balls. So it means uh, we still have the 6 here because they are untouched. So we have to write the 6 here because you took out 1 red ball, not blue. So the blue balls are still intact. It's going to be like that. So we are done with the first branch here. Now let's come to the second one. So suppose when you are taking out the first ball, it becomes blue, right? You take out blue. If you take out blue, did you affect the red? When you take out blue, did you touch red? You did not touch red because you took out 1 blue. So it means our red, we still have, our red is going to be, where is red? It's going to be 4. We have 4. So it means you're still going to have 4 because you took out a blue ball, not red. So red is not affected. So if you took out 1 blue ball out of how many blues? Out of 6. How many are you left with? You are taking out 1 blue ball out of 6. It means you're going to be left with 5. So this 9, like I said, if you take out one item from 10, you're left with 9. This is for this branch, and here also it's the same as this one. If you take out one item, which in this case is a red ball, from 10 you're going to be left with 9. So hence we have our denominator as 9 here. So now let's see if this is correct. All these numbers should give us 1, right? Let's start with this one. 4 plus 6 is 10, so 10 over 10 is 1. And then 3 plus 6 is 9. 9 over 9 gives us 1. And then 4 plus 5 is 9. 9 over 9 gives us 1. So it means this is correct, right? So now let's see what we have here. We have red, we have red, we have red, blue, we have blue, red, we have blue. It's blue. So this is what we have. Now we have to answer the question. Remember, the question was, what is the probability that both balls are red? Don't forget to write your probability here. I'm just showing you the numbers. So you're going to say probability of, let's say both balls are red. So you have to write that, let's say both balls are red, something like that. You have to write it here. Don't forget, now I'm only showing you the numbers, right? And then what is the probability that both balls are red? So we are looking for 2 reds. It has to be red. This is red here. We have red and red, because this is red, blue, red, blue. So what is the probability that both balls are red? So we are dealing with this one. So if we are dealing with this one, we have to look at these numbers, 1, 2. The number for the first red is this one. So we are going to have 4 over 10 and 3 over 9. So when they say what is the probability that both balls are red, so it means you must get red and red, not red or red. It's red and red. So you know, in probability, when we say and, you have to multiply, right? You have to multiply. So what is our answer here? This is going to be 12. This is going to be 12, and this is going to be 90, right? You need to simplify this answer. What is our highest common factor here? I think it's 3. So 3, how many times does it go into 12? It's going to be 4 over 90, 390. So here we divide this. We're trying to reduce these numbers. So we divide both numbers by 3, because I think 3 can go into 90. So here 12 divided by 3, we're going to have 4, and then 90 divided by 3, let's see, 9 divided by 3, it's going to be 3, and then the 0 is going to be 30, right? We're going to have this, let me see, but we still have 4 over 30. We can still reduce this number. We can still reduce this number by 2. So when we divide this by 2, we are going to have, here it's going to be 2 over 15. Half of 4, 2, half of 30, 15. So this should be our final answer.